Now let's talk a little bit about the history of Six Sigma. The history goes back to 1908, and it starts with Henry Ford. Henry Ford was an industrialist, a businessman, and he introduced the production line which started producing cars that were practically identical. So Henry Ford is considered as one of the pioneers in the Six Sigma methodology. This was followed by Walter Schwartz, who introduced control charts. And as we're going to learn, a control chart is a statistical process control tool that we use in order to determine if a process is stable, as we say, in statistical control. Then we have the A.G. Toyota, and he was the brainfather of the Toyota production system, which made Toyota very famous and also very wealthy company. Because at the end of World War II, Toyota was on the brink of bankruptcy. And just by introducing the Toyota production system, which revolutionized production in the car manufacturing industry, they made them very famous, they made them very successful. Another key figure is Bill Smith. Bill Smith was an engineer who was working for Motorola. He is considered as the brainfather of Six Sigma methodology. And finally, we have Jack Welch. Jack Welch was the businessman, and when he was at the position of the CEO at General Electric, he introduced Six Sigma across the entire General Electric, and he made it part of the business philosophy as well as the business planning and the business strategy. So, if you think about Six Sigma as a methodology, this has been adopted by some of the top 100 best companies in the world. There are companies like General Electric, like Honeywell, and Caterpillar, and many others. So what is the Six Sigma level? Six Sigma is a statistical term. It originated in statistics, and it refers to the standard deviation of a process about its mean. And we're going to give a definition about what is a mean, what is a standard deviation, etc., a little bit later in our course. Six Sigma derives from the bell-shaped curve, or the normal distribution curve, as we call it, or the Gaussian distribution in statistics, where each interval indicates 1 sigma, and 1 sigma corresponds to 1 standard deviation. So, in a normally distributed process, 99.73 of all measurements will fall within plus minus 3 standard deviations from the mean. And 99.99932% will fall within plus minus 4.5 sigma. This is a very important rule in statistics and a very important rule that we use in Six Sigma. We have the empirical rule in statistics, which is also known as 68, 95, and 99.7% rule in statistics. What it means is, if we look at a normal distribution like the one in the diagram. The majority of the data points of the plots are contained within plus minus 1 standard deviation from the mean, more specifically approximately 68%. Within plus minus 2 standard deviations from the mean, we capture 95% of all possible values and plots. And within plus minus 3 standard deviations from the mean, we capture 99.7% of all possible values under the distribution curve. What does it mean from a practical point of view? Let's talk about a process in the real world, the luggage collection system at an airport. If the data associated with this process follows the normal distribution, then 99.7% of all passengers, they will receive their luggage precisely, as they're meant to. There's a very small percentage of passengers that may be inconvenienced because their luggage may be misdirected. So this is the practical application of this. So this is how a Six Sigma level of quality looks like. This means that we can fit 6 standard deviations to the right and to the left of the mean, and this only leaves a margin of 3.4 defects per million opportunities in order to be potentially defective. So what is the primary goal of the Six Sigma methodology? It is to continually improve. Continually improving means that we improve a process up to a certain point, then we let the process run for a period of time, let's say 3 to 6 months, then we repeat the next improvement project. And this is how eventually we come to the ideal state of a process. Six Sigma is definitely a data-driven methodology. It uses a set of statistical tools and techniques in order to define the problem, analyze the problem, and evaluate how each step of the process is actually performing. Provides ways to improve efficiencies in a business environment in terms of processes, products, and services. And eventually this leads to the reduction of the operating cost in order to run a particular process. It improves the performance of business process, and this results in reduction of operating costs. This reduction in operating costs adds to the bottom line of the business. Six Sigma methodology also supports long-term business growth and business profitability. And these are two very important elements of each business strategy. Six Sigma can measure and can quantify a number of things. It can measure and quantify how efficiently each business process performs with regards to the customer requirements, and also how a business process either meets or exceeds customer requirements and customer specifications. As I mentioned earlier, the ultimate goal is not just to meet requirements, but to exceed customer expectations. We want to delight the customer, and we want to improve customer loyalty, which will improve the business profits. These are the key elements of the Six Sigma methodology, philosophy, and strategy. The first one is the customer. who is the customer? The customer can be an individual or it can be a legal entity, like a business entity, for example, a limited company. Employee refers to the people working for the organization that has already adopted the Six Sigma methodology, and process refers to the business process that are run by the organization that has adopted Six Sigma. So customer, process, and employee. We're going to learn a little bit later that we have the voice of the customer, the voice of the process, and the voice of the employee, and what these terms, mean within the context of Six Sigma. Six Sigma is results-oriented, focusing on continuous process improvement. This requires active involvement and visible support from the top management in order for the Six Sigma deployment to be effective. Continuous improvement activities. These help to identify business problems, analyze business problems, find the root causes, and eventually solve business problems. And this is when and where they occur. Most of the quality improvement methodologies use tools and techniques such as data sampling, control charts, process capability, which is calculated, and design of experiments. And they have been influenced by the theory of continuous improvement. The theory of continuous improvement is about making a series of small incremental changes that eventually results in a process that performs near its optimum capability. Now let's see why we should use Six Sigma. First of all, it helps design, develop, and implement and continuously improve business process. It helps design, develop, and launch products and services with Six Sigma quality from the design stage. It improves customer satisfaction and loyalty, which are very important for the reputation of a business and for the growth and profitability of the business. Reduces process variation, common cause variation, and eliminates the various forms of waste. And later we're going to talk about the 8 forms of waste. Eliminates root causes of problems and defects in a process, and reduces rework by getting things right the first time and every single time. Addresses key organizational and business requirements, and provides a competitive advantage to the business versus other companies in the same industry that have not adopted Six Sigma.